We're going to be talking about UX design for the consumer Internet of Things. I was going to just introduce myself a little bit. I'm currently an independent UX and product consultant. I'm also lead author on a book for O'Reilly with the tentative title, Designing Connected Products, UX Design for the Consumer Internet of Things, which should be out at the end of this year. I got into this through a couple of jobs. A couple of most recent jobs. I was the service design manager for a company called AlertMe in London, who make a connected home platform. So lots of the examples I'm going to talk about today are connected home related. Before that, I was head of research at Fjord in London. Do we have anyone here from Fjord in Berlin? Hello, hello. And as part of that, where I really first got into this was Fjord were involved in an EU consortium called SmartHOS, which was researching this is quite a mouthful, I apologise, the interusability of interconnected embedded devices, which basically means the Internet of Things. Anyhow, so I wasn't sure whether I needed to. I've been hearing lots of talk about the Internet of Things today. I wasn't sure to what extent I might need to introduce what I was talking about. I'm getting the sense that there's a lot of interest in this, and there's quite a lot of knowledge about it as well. What I'm primarily talking about with consumer Internet of Things is these kinds of embedded devices that are finding their way beginning to find their way into people's homes. So, we know about the thermostats and the fitness trackers, the scales. There are pet feeders, light bulbs. Door locks, bike locks, shower monitors, all these kinds of things that are sort of not mass market yet, which is my interest, but are starting to appear. Now, I've been working in UX for longer than I like to admit, and so my focus on all of this is really on how these things become mass market. I'd argue that a lot of this stuff out there at the moment is kind of still knocking around in the sort of early adopter space. There are some attempts to take things to a much wider audience. But, the technology's moving on. There are lots of challenges that we still need to solve. But sooner or later, we're going to see these things. There's a vast amount of potential amongst the late majority, if you like. And I think there are a lot of design challenges that we still need to address to make this technology appealing and make sense to those people. Now, I think the key to this really is that if you want to make something mass market, people have got to perceive it to solve a real problem that they have. That's the value. It's got to offer them a good solution to that problem. So that's about desirability and usability. And it's got to come at a cost in terms of not just money, but also effort that feels in proportion to the value that it gives people. Now, having worked in home automation, there's about a sort of 30 or even 40-year history in this field of connecting things in the home up, giving people ways of controlling them. And we're not all using it, are we? So this is, I love this advert, this is X10 Powerhouse for the Commodore 64. This came out in 1986, and it allowed you to do things like control lights and appliances and heating, and I believe also a security system in your home from your Commodore 64. And not just the Commodore 64, but also any telephone. Now, that obviously meant landline phones and not mobiles. But the reason I like this, and I have this kind of stuck up where I work, is because this is the kind of stuff that everybody falls over themselves about on Kickstarter now. And I think this is a reminder that if we don't get this stuff right, it will remain an interesting niche for people who have the time and the technical skills and the money to install these things. Now, when you start talking about consumer Internet of Things, one of the first thing that generally comes up in conversation is Nest. And I kind of want to sort of put Nest kind of over there a little bit, if you like, because I think whilst they make lovely hardware and they do some other things very well as well, this is expensive kit. This is, I'm not sure whether you can get it in Germany yet, but this is, I'm sure you're all aware of it. This sells for £180 in the UK, whereas the typical market price for a thermostat is about £40. So, it's a quarter, less than a quarter of that. It's actually think that there are ways. Nest is, in some respects, not as intelligent as some of the other technology that's out there. It's great, but it's not get too excited. I think what's really important about this is that it is possible to put that intelligence or greater intelligence into a cheap white plastic box, and we shouldn't assume that all things or connected products necessarily need to be expensive pieces of hardware. It's great to bring that level of design into something like it. This resets the bar, I think, for certainly for heating controllers, which tend to be quite dull looking. But it doesn't all have to be about high-end kit. And I'd like us to bear in mind that this should be something that's for everybody. So I also think that UX for the Internet of Things is also very much not about UI design. Now, there's probably many of you here who work on cross-platform type services. That was my background when I came to this stuff. And I realized that not only were there some of the additional levels that you have when you do cross-platform design to think about, there were a few more as well. So I came up with this concept of the design stack, sort of loosely modeled on a technical stack for the Internet of Things. So at the top, we have there's the UI and the visual design that you have on the individual devices. That's great. There's the interaction design, so the architecture, the UX architecture, the way that the services and the devices behave. There's interusability, which I'll talk a bit more about later, which is the designing interactions that span multiple devices. And there are some different considerations to think about there when you have got these interactions start on one device and move on to others. There's the industrial design, of course, very important. There's the service design. If you buy a connected thermostat, for example, that's powered by some kind of dependent on some kind of internet service. There's an expectation of ongoing service there. You have a different kind of relationship with a connected device than you do with a dumb box that doesn't talk to anything else, and that's a one-off transaction. And there's an expectation that this thing will carry on working. There'll be some kind of customer service. There'll be it's a different type of relationship. Then there's the conceptual model. I'll talk about this a bit more in a minute, but this is about how people need to think about the system. And this is much more, I found, to be much more important. The more devices you have that are working together, the more complicated this stuff can get, and the more important it is to think about it quite explicitly. Then there's productization. Does this thing feel like, again, I'll talk about this in a minute, but it does this thing, who's this thing for? What does it do for them? How does it function? What kinds of things does it do? And then at the bottom is the platform design. And this is what happens when you want to connect lots of devices and multiple services together. This is all about the ways of managing the complexity. And that probably sounds like a technical software thing, but there's a role, I think, very much for UX in that, in figuring out how these things should behave sensibly together. And again, I'll talk about that a bit later. But I think there's another set of issues as well, and these were things that kind of took me by surprise when I started working in this area. As a UX designers for digital services, we kind of work on the basis that things kind of work and they're sort of like generally connected, and and things work quite smoothly. With the web, we have an expectation that certain things will fail. Sometimes websites are sometimes there's latency issues. A website might be slow to load. Sometimes there are reliability issues with different types of services. So we all have experience that Skype calls sometimes fail, and these things are frustrating. But they're kind of part and parcel of our internet experience. We accept them. When you put that, this is not the kind of expectations that we have from the physical world, though. When you flip a light switch, you expect the lights to come on pretty quickly. You don't expect them to take 2 minutes. You don't expect the switch to kind of like your instructions somehow to get lost between the switch and the light to sort of do nothing at all. And so when you put the internet into things, all of those inherent issues that you have with the internet start becoming part of our experience of the real world. And I think this is going to start feeling very, very strange to people. Now, we can't make the internet a perfect thing. It's designed the way it is for many very good reasons. So I think there are going to be lots of things we have to do in terms of making services work in the right way that fits with the way the internet works, making things run over local connectivity if the internet's not the right way, where the internet's not the right way to do things. And also just kind of setting people's expectations that certain things may not necessarily function quite as they used to. And there are lots of things I think that are different about this, but I want to talk about what I see as being 4 of the quite fundamental challenges. Now, these are not sort of concrete things necessarily, like how do you design a setup experience, although those are all very interesting in their own right. It's kind of 4 of the more sort of conceptual type problems. This is about figuring out what a tangible problem is to solve, keeping the conceptual model simple, making distributed interactions across different devices feel coherent, and then manage the complexity that you get when you connect lots of different things together. So the first one is this is about productisation, essentially. This is about the consumer's ability to understand what something does and why they would want it. Now, I want to draw a contrast here between a class of things I would call products and a class of things I would call tools. And I think a lot of the Internet of Things type things that are coming out at the moment tend to fall more into the tool type camp. Now, I'll explain a bit more about that means, but I think that when consumers particularly often don't have they may have a problem, they don't have particularly expert knowledge in that domain. They may not have loads of time to figure out a solution to it. They look for something that promises to solve that problem and comes reasonably well configured to solve it. And that's what I would call a product. Whereas a tool is something that can do lots of different things, maybe requires a little bit of knowledge to get it to do what you want, and certainly requires a bit of an investment in terms of time to do it. Now, I'm going to talk about Nest Protect. Now, some of you might be aware of that there have recently been some problems with Nest Protect. In fact, it's been recalled. This is for anyone who doesn't know, this is the smoke alarm and carbon monoxide alarm that Nest brought out. The reason I think it's a great example is because the advertising for it, and this is a good example of a product, the advertising doesn't mention connectivity anywhere in there. I hate all that stuff about internet fridges and, hey, my fridge has got the internet. This is not my smoke alarm has the internet. There's one, this is all about why it's, in theory, a better smoke alarm. And then there's a mention at the bottom of, like, well, when the battery's low, we'll send you an alert on your phone. So it's not about the connectivity, is the internet part is not up front and center. The big problem about the Nest Protect, which is nothing to do with the productization really, but everything to do with the interaction design, is that it has a feature called Heads Up. So if you have a smoke alarm at home, you may have had the experience of, like, you burn some food, some toast or something, and the smoke alarm goes off. Heads Up was meant to be a kind of pre-warning that I've detected something, let me know if you have the opportunity to silence the alarm, which you did by doing that. And what was figured out quite recently is that if there is a fire at home, when people are on fire or in fear of catching fire, they tend to run around and do that. So you might inadvertently disable the alarm in the case of a genuine emergency. So that's obviously a little bit of something that requires a bit of rethinking and a lesson in the complexity of gestural interactions. But yeah, this is a nice thing. This is something people understand what it does and can figure out quite quickly whether they want it or not. As a tool example, this is the Belkin Wemo. Belkin have brought out a range of Wemo branded products. This particular one is a connected electrical socket. And it comes with quite a nice mobile app. If you look on Twitter, most of the things people report doing with these things is putting them on lamps, which is fine, but obviously they can do lots of other things as well. But I would argue that a connected socket is actually, it's not something that inherently has any value. It's something you have to figure out how to configure and control for yourself. So if you have a need for something to make something turn on and off, you have to figure out that you can use a connected socket to do that and set it up and configure it to do this. You can either use remote control, you can set it up with if this then that, so that it can be your lamp or whatever can be triggered if something else happens. But there's a bit of there's an imaginative leap involved in sort of getting to this. And then there's an effort of configuring it. It's not wildly complicated, but it's a little bit of a barrier. And I think that the difference between the early adopter market, for which this is perfect, and the sort of late consumer market, if you like, is that this is a little bit too much effort and energy and just figuring out why do I want this stuff. So valid product category, but I think this is not the kind of thing that will sell in the billions. Willing to be proved wrong. Now Belkin have also brought this out recently. This is the Wemo crock pot. I don't know whether slow cookers are a category, product category that has much interest here in Germany. I don't own one because I don't like the kind of food that they make, personally. But I think this is a really interesting product category, and it's a niche, but it's something for which the connectivity and the remote control aspect of it is actually a perfect fit for the context of use. So the way these work, if you're not familiar with it, you put ingredients in for a stew at the beginning of the day, go out to work. This thing sits there cooking them all at a very low temperature for the rest of the day, and then you come home and you have a one-pot meal, which is kind of the opposite of a microwave, but suits similar needs. What's so great, I think, about connecting this? Again, I don't expect this to sell in the billions, but because I don't think billions of people want these. But what's so great about this is that you've got, if you think about what you're doing with it, you're leaving a hot thing running when the home is empty, which is something that inherently makes people a little bit nervous. And also, the reason you've put this stuff in there is because you want to go out for the day, and sometimes you might want to come back a bit later. So not only can you keep an eye on what it's doing and make sure it hasn't blown up, but you can also say, I want to turn it down a bit, I want to extend the cooking time, all that kind of stuff. So I think this is the kind of thing, I don't think we're all going to have slow cookers, but this is the kind of uses, intelligent uses for connectivity and remote control I hope we'll start to see more of. And I think this kind of tool and product thing, it's not about people's technical ability so much as it is about the amount of attention that we have to spend on the things around us. Now, I don't have a problem with fun products at all. This is if you've seen Toy Mail, this is a physical device that allows children to send and receive voicemail, and it's really, really lovely, particularly the syncing experience is you get it connected to your phone by putting it over the phone and it flashes a pattern of lights. It's based on electric imp, if anyone's familiar with that. But we can't be playing with fun things for every minute of our lives. We have mundane things that we have to do as well. So this is the stick, and the other one is the stick and find. These are some little Bluetooth tags that you can use, stick on things that you're prone to losing to help you find them. There are lots of mundane things that have to happen in life, and we don't necessarily want to invest lots of time and attention in getting those things to work. Really, what we want is for those things to happen much more easily, so they demand less of our attention to free up time for more kind of interesting and important stuff. Just one more example of this. This is a demo of the FAA Smart Home. And this is, I'm not singling out FAA particularly. This is an example of something that I used to bang my head up against in connected home world. And this is the idea of modes. So when you have lots of connected things in your home automation system, a very common feature of those is the idea of modes, which is I press one button and a whole bunch of things happen, which kind of sounds superficially quite sensible, but some of these make more sense than others perhaps. And the one that really, really bugs me is romantic mode. Now this is a demo. This is what happens with romantic modes. That I think the blinds come down and the heating's turned up so that it's comfortable if you're not wearing so many clothes, and the fire comes on and some Barry White plays or something, and I think it's. The thing is that okay, that's all right, but quite a lot of effort goes into configuring that kind of stuff, and there's a sort of sense of advanced planning that's gone into this that perhaps if you met somebody and went back to their house and went, I've configured my home for romance, sort of either gives the impression that perhaps they've got a bit too much time on their hands, or perhaps they do this all the time and that's why they felt the need to automate it, and I don't know, maybe those things are not sending out the right message. Anyway. So the second point I wanted to talk about was about the conceptual model. So this is, I understand what this thing does. Okay, it's a product. So how does it do it, and how do I get it to do that? Now, conceptual models for unconnected devices tend to be fairly simple. So if you take something like a light, it's got a switch, and you have some power, and you flip the switch, and on comes the light. The problem is that when you start putting connectedness into things, you start having more bits that you have to think about, and more ways for things to go wrong. And actually figuring out, particularly when things don't quite work as you're expecting, what's happening and what to do about it requires you to have some kind of understanding of the system model. Now, when you buy something from a website, it's perfectly possible to buy something from Amazon without thinking about their servers and your browser and all the communication and stuff that's happening between them. But at the moment, and this is one of the reasons I think this stuff is not quite, mature yet, users will have to understand something about what the parts are and how they relate to one another. So this is the Philips Hue. There's a mobile app. There's a cloud service queue, kind of cheesy cloud diagram. There's a hub. This is the bit that there's a local network connection between the bulb and the hub, and then I think it runs on Zigbee, and that then goes out to the hub, then connects that out to the internet. And the reason you need to think about things like system models is because you've now got to figure out how the system is going to behave if one of those connections fails. So, for example, you could potentially have lighting rules for your lights that say when it gets dark or when this thing happens, I want certain lights to turn on. And those rules could potentially run on the mobile device, in the internet service, or on the hub. And the difference between all of those things is that if the mobile loses connectivity and then any rules on there won't run. If your internet connection goes down, then anything that's running in the internet on the cloud won't happen. If they're running on the hub, actually they'll probably keep happening, but you won't be able to see to find out remotely via the mobile app what's going on. So there's a case for a little bit of redundancy between all of those, of course. But there are interesting ways in which these things can fail. I worked on a heating system, and users would kind of frequently say, "Why is my heating system telling me the internet is down?" Or why am I, if I'm in the US trying to control my heating and it says my phone says it's 6 o'clock? Does that mean it's 6 o'clock where is it say turn the heating on at 6? Is it 6 o'clock where the phone is, or 6 o'clock where the heating system is? So it's all this kind of distribution and points of failure that makes things much more complicated. There's a couple of approaches you can take to this, that you can try to explain the system model better to people. I think there's a role for that. You might be familiar with the Berg. There's a product company now in London called Berg Cloud. They made a product called Little Printer. There's a number of other things, but this is the cloud bridge. This is the internet gateway for their product, and they've taken the line of explaining very clearly which of these things is currently working or not working, and which of the network streams is currently active. So that gives you a very easy route to figuring out why something's not working if it's not working. But I don't think we should take the line that we have to expose that to consumers for that's the final answer on how to do this stuff. There are other parallel types of systems, like things like the automatic gearbox, which many people are able to use very successfully without really understanding very much about what's going on inside it. So I think we have to set ourselves a challenge as designers that we have to get better at this stuff and not make people think about system models. And there's another thing that makes this conceptually complicated as well. So there's about 30 years of 30-year trend in UX design, first identified by a guy called Ben Schneiderman, towards direct manipulation interfaces. So this started out as things like WYSIWYG editing in word processors. The sort of modern equivalents on screen devices are things like Windows Metro, content-driven interfaces. So that the things that you can act on are right in front of you, and you can see immediately the consequences of your interactions. But I think that there's something about the Internet of Things that starts to break this down in interesting ways. This is a screenshot from Lowe's Iris home automation system in the US. It runs on, I didn't design this, but it runs on the technology platform I used to work with. And this is just a tiny part of a screen in which somebody is configuring a mode, remember those, with two lights. And as you can see, we've got 16, and we've already got, there's about 32 kind of things to specify, the states to specify on this screen already. And what I think is different about this this is not direct manipulation. This is about thinking about things happening in different times and in different places. And that, conceptually, is much more like programming it's a level of abstraction that we've sort of got away from, and now we're kind of moving back towards. People are not very good at anticipating their future needs, or at thinking about all the other things that might happen that might change what they've thought they change their needs in future. And so again, this is kind of this is getting more complicated, and I think we have to find better ways than this isn't going to scale, and we have to find better ways than this of figuring out how things should work. And I think if we're not careful, we're at risk of something that the design strategist Scott Jensen calls the surprise package, which is taking a successful mass market product and turning it back into an early adopter product. I regularly end up spending my entire dinner time sitting in front of various EPGs on my smart TV because I can't find anything to watch. And it used to be just a question of you press the button and press some other buttons and maybe you'll find something. It's much more. We've made TV a lot more complicated. We're going to be making everything else much more complicated. So the third thing I'd like to talk about is interusability. That's a big word. Some of you may have mixed feelings about the word interusability. I think most UX people kind of came to prefer to see that as being one dimension of user experience a long time ago. And really, what I'm talking about here is more about UX than about usability. But this is the term that's been getting some traction. This is about distributed interaction, so about things that happen across multiple devices. And there are a few things to think about here. The first one is about how you figure out which devices do what, and you might choose to make different decisions depending on who's going to be using this and how they're going to be using it. So there's on the left here we have the Tado heating system. This is a German system you may be familiar with. These are both heating controllers. The Tado one has a very, there's no controls on the thermostat, the in-home thermostat whatsoever. It's just a plain box. And all of that functionality has been offloaded onto the mobile device, which is quite an elegant solution in the sense that making hardware is expensive, putting controls on hardware is more expensive, and it limits you to having those controls that you've already specified, not being able to change things as easily down the line. So nice, elegant solution in lots of ways. But if you have people coming and going from the house who don't have a smartphone or don't use the app, then if they're cold, well, they're stuck, frankly. So this will work very well for certain situations. You've got one or two people living in a flat. Perhaps in other situations, it's not quite the right solution. The one on the right, this is a British Gas Hive. This is also not responsible for designing this, but it also runs on the platform I used to work on. This is a different, it's this wall thermostat. There's also a mobile app. They look quite different. They behave quite differently, but fundamentally they do the same things. So you have, if you're at home without a mobile app, you can figure out, you can still turn the heating up and down. So perhaps in some situations, the hardware is a bit more expensive. You might argue that trying to keep the price down on this kind of hardware, it doesn't always result in it is difficult to create good hardware to a certain price point. But if you want local controls, it's probably better. Second thing here is about consistency. This is not about making everything the same. This is about making device interfaces that work on specific devices, work well for that device, but also feel like they're part of a family. And I would like to draw out Nest here because I think they've done a really nice job of this across the thermostat and the mobile app. So there's some obvious visual similarities, colours and fonts and that kind of stuff. The interaction for turning things up and down on the Nest on the thermostat is a rotating bezel, which makes a little clicking noise. Now, rotating things don't work very well on touch screens, certainly not if you want to be quite precise about what you're doing, which is generally how people use heating. But so there's an up and down arrow for things like temperature adjustments. But when you tap on those up and down arrows, it makes the same clicking noise that you hear from the wall stat, which I think ties those things together in quite a nice way. The third thing is about continuity. Now, this is continuity is one of those things you get in films that make sure that someone's hairdo doesn't change between scenes and kind of create these weird, jarring experiences. In a similar way, I think in UX design, you don't notice it when it's done well, but you do notice it when it's done badly. And this is where a lot of the really challenging problems with designing for the Internet of Things occur, because a lot of the things are actually not connected all the time. In many cases, because they need to they need to conserve power. There's in terms of the first aspect of this, in terms of experience, is about fluent cross-platform interaction. So I do something on one device, and I can immediately see the results on another. And I think if you've to another Berg output. This is, if you haven't seen the video for they did a washing machine prototype. They hacked a Zanussi washing machine, put it on the internet, intercepted the wash programs, stuck a new interface panel on the front and created a mobile app for it. It's a prototype, but it's a really, really lovely piece of design. And you see the user just kind of doing something on the mobile app, and instantly the display updates on the machine. It's lovely. It wouldn't be that reliable or that responsive in real life necessarily over the internet, but we'll allow them that for a prototype. The problem is that a lot of the things in the Internet of Things are battery powered, and if they're battery powered, then they're not necessarily connected all the time, because connecting to networks, particularly Wi-Fi networks, uses an awful lot of power. Now, this is a system, this is a heating system, just a schematic of a heating system I worked on, where the heating controller, because it ran on a battery, because that's the norm, certainly in the UK, only connected to the network once every 2 minutes. And that didn't sound like a big deal to me until I realized that actually it was possible to have these instances where you were standing in front of it with a mobile phone and you say, I want to turn the heating up to 21. And for up to 2 minutes, the display on the wall was giving you different information about the status of the system. Now, being able to see what the status of a system is one of the really, really fundamental principles of usability. And yet, this is in this situation is temporarily going to be broken. So we really have to find. This is something to be aware of if you're designing for this kind of stuff. And we need to find ways of managing this. For something like a heating controller, it's probably acceptable that things are a bit out of sync for a while. But if you were looking at if you wanted to know, for example, whether there was an alarm was going off, or whether an elderly person who had a false alarm was safe at any given point, these things really, the consequences of this become much more important. So the final thing I'd like to talk about is about what happens when you connect all of this stuff together and the kind of interesting design problems that creates. So we looked at the hue beforehand. There's a lot of the products that are out there at the moment are these kind of walled gardens. There's a single manufacturer. There's a few devices maybe. There's a gateway, or in some cases they connect to a mobile, which is what the Apple HomeKit system will how that will work. And then there's an app, and the app does. And if you have several of these things, you have several apps, and that's all very well, but it doesn't really scale up. And of course, the way people, what we want to do with this stuff is get these things working together. These are some screenshots from a video that Ericsson put out a couple of years ago called The Social Web of Things. And I actually don't really apologise if there's anyone from Ericsson here, but I actually don't like it very much, because the vacuum cleaner and the oven and the house and everything they're all talking to the guy who lives in the house through some sort of Facebook analog, and it's not really clear to me how he manages to get anything else done with his day, because he has to engage with all of these things so much. And in fact, at the end of the video, his girlfriend leaves him. So, perhaps because he spent too much time talking to his house, I don't know. But what it does illustrate, I think, is this desire for us to get these things working together in sensible ways. And I think we're not at that point yet. There are lots of technical challenges that are being worked on at the moment, but the point of the internet, right, is interconnected computers. The point of the Internet of Things is going to be interconnected things, not these, not standalone little apps. So things can get quite complicated though when you have multiple systems or multiple types of systems in the home. I'm going to talk about home stuff here because I think it's in the home where these things are sort of, initially get most visible. So let's imagine that you add a lamp to your connected home system. Now that's plausibly something you might expect to control along with the other lighting, which is fine. It's also plausibly something that you might want to control use as part of the security system. So, for example, you might want it to turn on and off to make it look like there's someone in the house, or you might want it to turn on when an alarm goes off to provide some light to let the burglar know that they can be seen and to provide some light for a video camera to run. So you can't just kind of, where does this go? Where do you put it? And of course, as soon as you get to think, you don't have to have very many devices or very many people in the house or very many types of functions before it starts to get really complicated. So this is it's an illustration of what. Let's imagine you have 3 people living in a home that have slightly different access privileges to some of the technology, and you've got a couple of lights, and you've got a thermostat, and you've got some motion sensors, and you've got a camera. And so what you're trying to do with those things is lighting and heating and security. Within some of those systems, you have subsystems for which certain people maybe have access and some don't. So, for example, some people can set the heating schedule and some people can just override the current temperature. You've got devices that might be working as part of different services. So lighting could be lights can work as part of lighting and security. It's quite common for motion sensors to have temperature sensors in them as well. So they might be feeding information into your heating system as well as the security system. So you end up quite quickly with these kind of many-to-many relationships between things, which can become very hard first of all, technically to keep track of, quite hard to test systems like that, and really hard for users to understand exactly what's happening. I apologise for a couple of wordy slides. But so across a range of home services, you've got things like services, so the security and the lighting and the garden watering and whatever. You've got lots of devices, so motion sensors, lighting, sprinklers, thermostats, cabinet sensors. In the US, gun cabinet monitoring is a thing. Control, these things have controls, so they can be on or off or up and down or more or less of this, or timers and schedules. You expect some consistency between these types of controls, but of course they could be applied to different types of system. Things want to tell you stuff. They might be alarms. They might just send you a message. They might need to give you some status information. There might be presence. This is a real hotbed of kind of complex social context. Most people don't really like the idea of that I've researched so far. Don't like the idea of kind of the house that tracks exactly who's in and who's out at all times. But you might have things like who's near, who's far away, should the heating be turned on in 10 minutes, who's available, unavailable, whatever, who's got rights to do certain things. And then you've got the people who live in the house, the people who come to the house, the people who have access to the physical property. Maybe you've got a builder in, or the people who you actually give access to the service UI itself. And then, last wordy slide, I promise. You've got the types of things that people want to do with those. And the kinds of home automation systems that exist at the moment have things like scenes, which are kind of loosely room-based, don't have to be, rooms or modes and all this kind of stuff. But they're quite rigid. There's not very many of them. And the things people want to do are more kind of like, well, this device over here, all the devices, these things in this part of the house, but the way they carve up the house might be different depending on what they're trying to do. There are things that are to do with time or state or kind of the activity I'm doing. So I might want to watch a film and I want certain things turned up and turned down. It might be about keeping the house at some sort of optimal temperature or energy usage. Might be about allowing certain people to do things or not. And it might be about telling me things about specific people, like kids or somebody that I'm trying to keep an eye on. And these things don't really kind of easily map to the other category of things. So I think the reason I think there's a UX challenge in the software platform is about figuring out logically how you stitch all of these things together. And of course that gets even more complicated when you've got different manufacturers who've got different types of technology where there are slightly different ways of classifying these things. Even something as simple as swapping out one fitness monitor for another can be difficult. At the moment, you change change brand, you lose your data. Even something as simple as saying, well, I want to use a different brand, but I want to keep my data, is a challenge because those things have different structured APIs and the data is held in different formats. So there's a UX role in all of this, in trying to make the UX make sense despite the complexity. And this is all about making things feel like they have common sense. But that's not quite as straightforward as making things feel straightforward without them actually being straightforward. So, of course, your ideal experience, perhaps, if you add a light to the system, as it says, announces to the system, "Hello, I'm a light. I'm new. Here's what I can do." And the system goes, "Okay, well, but I now know what you can do, and user, here are some sensible things you might want to do with this." And that's actually quite, we're still not really quite there yet. We're making some progress with the first part, but we're still not quite there yet. And this requires things like domain models and ontologies, and it doesn't necessarily require full-on AI or anything, but it's still quite a challenge. So the final thought I'd like to leave you with is really that doing good consumer user experience design for the Internet of Things is deceptively hard. Making things work as consumers will feel that they should work is really non-trivial. There's a guy called Larry Tesler, who, amongst other things, used to be a VP of Apple, and he came up with this idea of the law of conservation of complexity, which is that you can't get rid of the complexity. So if you want to make the user interaction simpler, you have to make life more complicated for the designer or the engineer. So I think I hope that we'll all be able to make some progress with that in future. But I'd like you to take away as it's a bit of a challenge. Thank you.